Hello Precalculus student, this video is for chapter 3.9, Modeling Using Variation. There is two variation relationship between variables, direct variation and inverse variation. So if we know, and then the third one is joint variation, which is a combination of direct as well as inverse variation, and it can involve multiple variables only. So let's look at the two fundamental variation, direct variations. We say two variables are related by an equation of the form of y equal to k times x to the n is, n the exponent. Then we say x to the n and y has direct variation relationship. So notice when we look at these terms, direct variation or varies directly or proportional. So all these are actually the same thing. When you see these kind of sentence, it can be translated into y equal to k. K is is a constant related to x and y, x to the power n. Now x can be x to the 1, it could be x squared, it could be square root x. So long as the sentence, the math sentence say direct variation or proportional, you can immediately translate it into an equation like that. And all direct variation graph also are linear and also pass through 0, 0. So when I say linear, I mean kx, of course. So the input is x. So how do I solve a direct variation problem? So usually it is easy to write this equation, but we want to find k, and also we want to use the equation to solve for y. So a general direct variation problem goes like this. Identify the input and the output. The output is the one that varies, and then the input are the one that it is being varied, varied, varied with, okay, with whatever. So don't mix them up because the variation constant is different. And then usually they will give you a pair of x and y so that you can solve the constant of variation. After you solve the constant of variation, you will have the equation. So this is the most important thing. Use one given x and y. And then you use it to find, after you solve the variation constant, k is called a variation constant or the constant of variation, and then you can use the equation to find the unknown. So let's do an example. So the question usually goes like this. There's a quantity y varies directly. So if you see the word vary directly, you immediately say that, oh, this is a direct variation. The output is y because it varies with x. So I write y equal to k times x. So this is the setup, step 1 setup. And then you need to find, so this is step 1. You want to find k. To find k, you need one pair of x and y. So when y equal to 8, x is 5. So you would plug it in. 8 is equal to k, which is an unknown, but 5. So then if you divide it by 5, k is actually 8 over 5, right? So get that. So that means I plug it back in. So the equation, once you solve for k, then you will have the equation being y equal to 8 over 5x. So this is one of the answers. So find the variation constant. This is the variation constant using 1x and y. And then find the equation. The third thing is to find y when x is equal to 6. So if x is equal to 6, what happened? So you would just use this times 6 and you would get the answer. So 48 over 5 or equal to 9.6. So that is the answer. So basically, if you know y and x vary directly, you write y equal to kx and then you can find the equation. Example 2. In here, they say y vary directly again, but not with x, but the square of x. So the basic equation is y equal to k x squared. I just don't know what k is. Now, I still have a pair of x and y, right? So this 2 will be used to solve for k. So I plug in 24, y equal to k, which is unknown, 3, but I have to square it because the information that's given to me is y does not vary directly with just the value of x, but square of x. So 24 equal to k times 9. K would equal to 24 over 9. Simplify it. K would equal to divided by 3 is 8. Divided by 3 is 3. So it's 8 over 3. Use fraction as much as possible. So y equal to 8 over 3x squared is the equation. Okay. Find the variation constant. So this is the variation constant, and this is the equation. Now, once you have the equation, you can use it to predict y. Y equal to 8 over 3. Oh, x is 4, so I need to do square. So it will be 8 times 16 over 3. What would that be? 8 times 16, 128. So 128 over 3. So that's the answer. So basically, you would use one given pair of x and y, the fact that they have a special kind of relation to find the equation. Once you do that, you use it to do prediction. The second variation is called inverse variation. So when the statement, so usually what inverse variation goes would be when x goes up, y goes down, and the relationship can be written as y equal to k. Instead of times x to the n, is divided by x to the n. And we call them inverse variation relationship or inverse proportional. So how do I solve this? You would write a basic equation, y equal to k over x to the n, and then use one pair of x to solve for the variation constant. Use a x and y pair, plug it in here to solve it, and then use the equation to find the unknown. So very similar to the direct variation, except your basic equation is y equal to k over x to the n. So look at the first example. A quantity y vary inversely. So this is the keyword, inversely with x. So your basic equation will be y equal to k over x. They didn't say x squared or whatever, just inversely with x. So you say k over x. So this is the basic equations. And then to solve for k, you would plug in xy 9, x is equal to 9, y equal to 8. So you say 8 is equal to k over 9. Okay, solve for k. K times 9 on both sides. K is 72. So your equation is, so this is your variation constant. They always want you to find. Y is equal to 72. So you put back 72 over x is the equation. So you box it. It's the equation. And then you wanted to find y when x is equal to 4. Y equal to 72 over 4, and that's 18. So this is the answer. And you can see when y is 8, x is 9, but when x change to 4, y increase. Okay. When x decrease, y increase. So this is usually a phenomena of inverse variation. Example 2, a quantity y inverse vary inversely with the square root of x. So what is the basic equation? It will be k, because it's inverse, you do divide. Square root of x. Inversely means dividing. Now I want to solve for k, so I use these pairs to solve for k. So 8 is equal to k over square root of x. X is 9. So 8 equal to k over 3 times 3 on both sides to solve for k. K is equal to 24, right? And then, so I would write the equation out, so this is one of the answer. They want this. They also want 24 over square root x. So this is my equation that I figured out by using these pairs of x, y. Now, if my x is 4, with 24 over square root of 4, so that would be 24 over 2 equal to 12. So I'm going to do another example, another videos on joint variation. So these two are the basic, and also use joint variation to solve work problems.